All right, welcome back, everybody, to the Additive Snack Podcast. I'm your host, Fabian Alefeld, and today we are talking about what it really takes to build a additive manufacturing center of excellence within a corporation that is more than 150 years old. And therefore, there is no better guest to take us through what it takes to do that than Kristin Mulherin. Kristen is the Director of Additive Manufacturing Technology at Hubbell, and therefore is the perfect person to talk to about this. If you don't know Kristen, well, you probably have been living under a rock. But if you don't know her, she's been a very influential voice within the additive manufacturing industry for many, many years, with stops all the way from Northrop to HP to Nexa. She also started the Implement AM series, if you're familiar with that, and is now, like I said, the Director of Additive Manufacturing Technology at Hubbell. And if you don't know Hubbell, Kristen is going to give us a bit of a lesson, but they are, of course, a major player in the electrical industrial solutions space, really the company that keeps the lights on and keeps our grid running. So crucial technology meets additive manufacturing technology, and that's what we'll talk about today. But of course, we'll also learn a bit about Kristen and her background. So therefore, I'm super excited to have you on the show, Kristen. Welcome to Additive Snack.
Thanks, Fabian. I'm really excited to be here. This is going to be fun.
I think so too. And before we dive deeper into technology, into Hubbell, into what you've built so far, let's talk a little bit about you. You've had a really interesting career in the additive manufacturing space. So take us a little bit through your journey. How did you get into additive, and what were some major stops along the way?
Gosh, so I think my story is a little bit different. I haven't spent my whole career in additive. So I started my career, actually, as you mentioned, at Northrop Grumman in the aerospace defense sector. I realized I was there for several years, and I realized pretty quickly that wasn't really my space that I wanted to be in. Long story short, I ended up being one of the first employees at a startup, that advanced materials startup called American Elements, and that was kind of my entrance into additive, because when I was wrapping up that role, I was contacted by a recruiter for a company called LPW. And some of you might be familiar with LPW. It was sold to Carpenter and became Carpenter Additive. So I joined them as their chief commercial officer, and that was my first role in additive, selling the
Wow.
metal powders for laser powder bed fusion. So it was a great introduction. I learned so much and very, very quickly. And it was just a really good way to get entry into the market. Then I worked for a couple different companies across the industry. I joined Thermo Fisher and helped them sell FEMs into the metal additive manufacturing space. And then I joined HP. And HP was a great experience, because there is when, I made that transition from metal to polymer. So I think everyone who's on the metal side of additive manufacturing we think, oh, we're better than the plastics guys, And so I joined HP as a product manager on the metal side of things, but then ultimately moved over to MJF. And I got this whole new experience and this eye-opening experience on what the possibilities are. And it's not just, FDM printing. It's so much bigger than that. And there's so much potential for the laser powder bed fusion technologies on the polymer side. So that was really interesting. After I left HP, I started my own consulting company called AM Cubed, where I worked with various companies across the additive manufacturing space. And it was really primarily working on market development and helping them enter the companies within the additive enter the space and grow and work on their strategy and marketing. And that was at the end of that is when I started Implement AM with David Tucker. So David Tucker was a colleague of mine at HP, and he had reached out and realized, and David's a really skilled designer, industrial designer. And, we had the same kind of viewpoint on there was a lack of education in the additive space on identifying good applications for additive and getting that change of headspace that's so critical. I talk to people all the time in terms of what's one of the hardest or what's one of the reasons why additive isn't more of a mainstream technology. And I think largely and maybe even number one reason is because it's hard to get people to think differently. So that was kind of our goal with Implement AM, was to get people to think differently and look at things in a different way. And then after that's when I joined Hubbell. So I have worked across the whole industry from the powder manufacturers to the service bureaus. I had a couple of service bureaus that were my clients when I was at AM Cubed, machine manufacturers. I guess Nexa was in there somewhere. I got to throw Nexa in the mix. That was the SLS printer. So it's been a wild ride, and it's been awesome.
Yeah, yeah. You've seen really almost all aspects in the additive process chain, from the early stage identification to materials to systems to inspection equipment.
Hubbell was such a great opportunity to come by because it really, I feel like from the second I joined, all of those experiences, and some of them, people from the industry recognize it's a tough industry. And so some of those, not all those experiences were the best experiences, but gosh, I wouldn't change a single one of them because all of those experiences came to what I'm doing now, and they all feed
Yeah,
into what I'm doing now. And so it's awesome to finally have that, destination as a result of all of those experiences.
sure. And I'm sure your work at Hubbell is not gonna have no obstacles, but if you've read the book, The Obstacle is the Way, then it seems like you're living that throughout your career. And you also were very influential in the Women in 3D Printing organization. Can you talk a little bit about that?
Yeah, so I joined Women in 3D Printing as an ambassador, just like a lot of others. There's over 100 chapters of Women in 3D Printing in across the world on all six continents, outside Antarctica, of course. And so I joined as an ambassador in Portland, Oregon, when I left HP, and I just gradually moved up and ultimately joined the board, and then finally became president, working with Nora Ture. So she's still very involved, and essentially we just needed more help because it turned into something that was so much bigger than one or even the board could handle alone. So her and I worked very closely, and I was president of Women 3D Printing for a couple of years, several years. I know it was more than two, but it was intense, and I loved it. But when there was time to step down, it was definitely time to step down because it was unpaid. And I always joke, I always say it was what I did in my free time, which I didn't have a lot of free time.
Yeah.
And so it was quite a bit of work. And it was interesting because I was doing consulting at the time as well for part of that. So I essentially had multiple jobs going at any time. And when I got to Hubbell and then sold off Implement AM and no longer did AM Cubed and finally had stepped down from Women in 3D Printing, it was kind of a shock to my system to have just one singular job.
Yeah, I could see that.
Yeah.
I could see that. But yeah, I mean, it also helped. It really puts you on the map for a lot of people, and I think
It brought me
your opinion is
incredible
very
exposure,
much,
for sure.
yeah, yeah. Your opinion is very much valued in the whole industry. Now, you mentioned Hubble, and I think it's an interesting step too from, right. I think your last step was Nexa, which was small startup, probably super agile, into Hubble, which is a very established, publicly traded company. First of all, give us a little bit of a Hubble 101. Who's Hubble?
The best way I can describe it is wherever there's electricity, there's inevitably a Hubbell product. Harvey Hubbell, who started the company 150 years ago, invented the pull chain light switch, and the American electrical receptacle.
Oh,
So it's got its roots in just basic. When people join our team, I make sure they understand it's not sexy like aerospace 3D printed parts. They're much simpler, but it's a really interesting company because it was largely built by acquisition. So it has a lot of unique business units that all address different parts of the electrical market. And so I've learned a huge amount, and I get exposure because I get to work with all of them, because they all in different forms need additive manufacturing assistance. But it's been a really interesting experience to learn about that side of industry. I hadn't been familiar with it before joining.
yeah. What was the biggest surprise when you, like, on your first few weeks at Hubble, moving from the fast world to the corporate world? What were some of the culture shocks you
Oh gosh,
experienced? I'm sure there were a few.
the culture shock. I think I was very fortunate when I came on board that my boss he had done, and the CTO of the company had done a lot of work to identify whether additive manufacturing made sense at Hubbell or not. And they working with different consultants, and then they sold the idea to the C-suite of the company, and the C-suite was on board. So when I joined, it was a really they set me up for success by I didn't have to convince the senior leadership that this was a good idea. They had already been convinced. So that was a really I guess that was surprising in itself because you're used to having to sell additive and get people on board. Um,
Yeah.
but yeah, the surprise, the shocks have come slowly over time, I think, as you get to know more and more about the company.
Yeah. Yeah. Once the honeymoon phase is over. So let's talk a little bit about that. So I think there's one of the reasons why it's super interesting to talk to you is because there's, of course, many other people out there who work at established companies and with an established technology. They see there's potential for additive, but it's somewhat difficult to make that step from exploring to doing, right? And you're now in the phase where you're establishing a center of excellence. Can you talk a little bit about the vision you had, how you approached that strategically, and what maybe even some of the hurdles and obstacles were that you didn't see coming?
Oh gosh. So I mean, there was definitely it was not a straight path. When I first joined, the idea was really to build a relatively small center of excellence where the innovation could be built and the ideas could be built, and then we would then educate essentially the various business units across the country on how to implement additive manufacturing. Very quickly, as I think a lot of people know in the industry, the filling the capacity of the printer is everything in terms of your success. So it's very clear. It became very clear to the organization pretty early on that we actually needed to centralize the additive manufacturing because that way we can support all the business units and we can pull in parts from different groups. It's interesting to me. I'm used to working in the additive manufacturing space where you take for granted a lot of concepts and a lot of ideas. And there's a lot that I still have to continually impress upon people. And one of them is that we can print different parts in a single build. That people still are just shocked by that. I can take a part from our entity up in New Hampshire, and I can take a part from our entity down in Missouri, and I can throw them in the same build, and that will maximize our efficiency. So that's an interesting thing that we've come across. The another one that just actually came up today was the idea that we could print thousands and thousands of parts. And I was having a conversation with someone, and I said, look, this is we don't have a lot of these low volume parts. And I said, well, we don't really want low volume parts. We want high volume parts. And he said, well, my idea of high volume is very different than your idea. And I said, well, we can do tens of thousands of parts. And he was shocked. And it was funny because I've said this before, but I think I was saying to someone earlier, I think people hear it, but they don't believe it. So then they choose to forget it. In my experience so
Yeah.
far. And I think it's the same thing with building the filling capacity of the printer.
Yeah, and I mean it's probably also that person was exposed to additive 5-10 years ago, where maybe his statement was true,
Yeah.
right? That higher volume is not feasible, and we live in a very very different world.
Which has been a really interesting part of the building this center of excellence because I've now been here for over 2 years, and when you look at the speed at which the additive manufacturing industry changes, essentially, I've
Yeah.
been building the center of excellence, and I had a plan 2 years ago, and there's a lot's changed in 2 years, and with the technologies, with the advancements, some of the technologies that we thought would be more advanced by now have not gotten there. Some of them that we didn't even know existed 2 years ago are now coming up, and we thought, wow, we should look into that. So it's been interesting, again, working within a company this size, where it does take some time, it takes some momentum to get all of the key players on board and make sure everyone's aligned. That's where we lose a little bit of advantage by not moving a little bit faster.
Sure. Yeah. And then how did you decide on vertically integrating technology versus having supply chain partners?
We've been that's a
Yeah.
pretty easy thing to explain because it really just boils down to cost and lead times. Hubbell parts are extremely low cost. They are low cost parts. They're simple parts. We're competing, with parts across Hubbell that are costing, $1, $2, $4. They're not, we're not talking about, again, these $1,000 pieces of equipment at aerospace companies or medical. So, we simply couldn't do scale to the size we wanted to and do production using contract manufacturers. The other one is speed. It's just the turnaround time. One of the biggest value drivers at Hubbell, and I think at most industrial organizations like us, is that we can turn things around fast. Most of the people at Hubbell are used to lead times with suppliers being 18, 20 weeks at the best case scenario. And so we can sell them, look, we can make those parts for you in 2 weeks, 2 to 3 weeks. That blows their minds, and it's a great selling point. But then we get bogged down with the contract manufacturer, and that's no longer the case. I did find when I was doing an analysis and sharing it with our leadership that literally, without exaggeration, the same parts that we were trying to get made at contract manufacturers while we were building this facility, they were literally 10 times as expensive and took 10 times as long. And that's just not going to be sustainable in the long run. It honestly made it quite difficult to even get up and running in the first place.
Wow, interesting. Well, let's talk a little bit about your technology stack. I mean, I've been to your facility. I think it's also cool to mention that you took over an old desktop metal facility.
We did,
which
yeah.
is
Put it to good
cool. I'm not sure. Yeah, I mean, which is from a baseline a pretty good starting point. How did you approach this? You started almost basically with an empty facility. What are some of the steps that you took to make it ready for your technology stack? What type of technologies do you have in your center? Can you talk about that?
I could talk a little bit about it. I mean, we settled on this facility. We looked at a lot of facilities in New England. We had the headquarters for Hubbell's in Shelton, Connecticut, and so we knew we wanted to be somewhere near the corporate headquarters, but also, I think we are just outside Boston now, and I think everyone can recognize that Boston is definitely one of the central locations for additive manufacturing. And so, I think one of the hardest things starting something like this is finding people with deep backgrounds in additive to join the team. And we knew that we would be able to find those people by being in Boston versus some of the other alternatives that were, presented to us. So that's kind of how we ended up here. We ended up in this facility, and it's been a blessing in disguise in a lot of ways because one, Desktop Metal had done some work. They had built out some of the infrastructure on internally, and it was so that saved us a huge amount of money, huge amount of capital investment up front. The other thing that's kind of funny is we ended up with a facility that's a bit larger than we had thought we needed or wanted. But that's because the kind of power requirements for additive manufacturing equipment is very high. And it was easier to get a larger facility. The very few facilities, the smaller facilities have the power that we need. So it was more economical to get a bigger facility that already had the power that we needed versus having to install the kind of power that we needed. So that was another kind of interesting development, but it's worked out well because I can see, I have a very clear vision on filling up this facility with a lot of equipment over time. And now we're just going to be able to be bigger and better than ever.
You'll still run out of space.
So, yeah.
And then what technologies do you have on site now, or are you planning on having on
We're
site?
looking at all sorts of technologies. I mean, binder jetting is obviously something we're very interested in because it is the low cost, high volume solution. It's the laser metal technologies are expensive. So while there's opportunities for the laser metal technologies, they're a little more far and few between because of the high cost of manufacturing. Whereas binder jet, we can get down to those single digit dollars and competitive, in some parts even less. So that's definitely one of our focuses. We're looking into multiple polymer technologies as well. I think laser polymer is a really obvious one. I think it's probably in an industry like ours where we have something like 300,000 or 400,000 SKUs. We have a very huge selection of parts to look at. And I think any industrial company that has a large catalog, laser polymer is a really logical solution because it's probably the most versatile. You can use nylon 11 or nylon 12 and for so many applications. And I always tell people, one of the best applications I think for the nylon 12 parts is replacing aluminum parts that don't need to be conductive. Obviously, a lot of Hubbell parts need to be conductive. So that rules those out.
Yeah.
But there's also a lot of
Yeah.
parts that, you can use the ion 12 for that as long as they don't need to be conductive. So I think laser polymer is a real obvious one for those purposes as well. And then we're looking at photopolymer solutions. We've looked at a couple emerging technologies. There's one technology we looked at that's an alternative essentially to sand casting. But they're not quite there yet. We need to get their costs a little bit lower and their volume throughput a little bit higher to be able to implement that. But I definitely see potential for that down the line as well. I have all sorts of exciting ideas as well to implement. I think there's a lot of opportunity to do AM enabled investment casting. There's ways to branch out and do things even beyond just straight up additive manufacturing.
Yeah, it's interesting. You're implementing established AM technologies, but you're also keeping your finger on the pulse of new developments.
Well, I think
And what those would
that's a really
mean.
good way to put it because we need to invest in the established technologies up front because like anything, we've got to prove ourselves. And so, we have to start with the last thing we need right now is to be battling a technology that's, just off the
Not
shelf.
ready.
Um,
Yeah.
but we also, again, back to the cost drivers, we have to be investigating some of these new ones because that's, unfortunately, I think there's not a lot of focus in the industry on driving costs down. I think the focus is bigger and better and faster and faster obviously helps, but more complex designs and making things better. The quality, I think we're okay there. I think the quality is fine for our applications. It's now we need to get the costs down. So that's the kind
Yeah.
of technologies we're interested in.
Yeah. And I think we are at a point in time of the industry where I think we have reached that point, right? Where the technology is mature enough from a property perspective, it is mature enough from a repeatability perspective. And now productivity, I think, is one of the key drivers for new systems in various technologies, from laser powder bed fusion to others.
Yeah.
So I think you're
Well, I think
the
it's just not gonna be feasible to make parts that are 5 times as expensive as traditional manufacturing. We've found a lot of applications where we could be twice as expensive, and the value it
yeah
provides in other ways definitely compensates for that more expensive just upfront cost. But not 5 times.
yeah. Let's talk about that actually. So how do you manage, or how does Hubbell manage that? So you do oftentimes have the cost versus lead time discussion in additive, especially when it comes to replacement parts of conventionally manufactured parts. So how do you manage those conversations within Hubbell where you may be more expensive, but you can deliver faster? Where is that value overlap that justifies maybe a bit more of an expensive process?
Yeah, I mean, well, there's multiple value drivers to look at, and to be frank, a lot of projects that we work on, they touch more than one value driver, and that's when it's really exciting. Lead time obviously is a benefit. It's hard to quantify lead time from a financial point of view because typically the finance people don't really view it as new value. But everyone recognizes that it's good for the company to be able to do things faster. So there's, lead time
Yeah.
is definitely one of the big ones. I think part consolidation is another one. And you can get just part consolidation alone can drive so many different value drivers. One is it's reducing the amount of labor involved in assembling the ultimate assembly. That right there is a big savings. The other one that people don't talk about really enough, I think, is reliability. If you take a part, we have one that we're working on right now that was 4 parts, and we printed as a single part. And the reason we did that is because the part of the one of those parts was shearing off when it was being used. So if you print it as a single piece, that's no longer going to be an issue. So you get reduced labor, you get increased reliability. There's multiple aspects of that there as well, and you get an increased design freedom, of course, as well. So that's just one, and then. Gosh, what are the others? We can do one of the ones I like as well is it's about eliminating the changeovers in a high run production line. So if we can print the lower runners, which we can because we can do multiple low runners in a single build, then they don't have to do the changeovers, which costs the company a lot of money to change over a line to make those low volume parts, whereas they could just run it continually and not have that issue. So there's a huge amount of value drivers, and that's one of my biggest responsibilities here, and has been since I joined, is educating the engineers, the product managers, the supply chain people across the organization on those value drivers, because they just think of straight up manufacturing cost.
Yeah. And how do you do that education? Do you host workshops with different teams? Do you invite them to your center of excellence? Do you have internal case studies? Do you have
We
how do
do
you
largely what
educate
I'm doing right
the
now is lunch and learns. So once a month
okay.
we do a lunch and learn on a different topic, and we've been covering a lot of the different topics. And I start every single one, and probably everyone's starting to get tired of it, but I'm not going to stop with a slide that shows what do I have? 7 value drivers that we could consider for additive manufacturing. I started every single time because I beat it into everyone's brains. Like, look, this is not about the part cost. It's about all of these other advantages that you can get from additively manufacturing these parts.
Okay. And those are then the lead times, the consolidation, freedom of design,
Customization, low
multiple.
volume,
Yeah.
you can do any kind of customization.
Yeah.
Elimination of
Yeah.
tooling. That's the obvious one I think most people are familiar with. We don't have to pay for tooling. But that's a tough one to compete against, because when you look at, people don't take into consideration the cost of the tool when they're looking at the price of a part. They're looking at just what it makes once the tool's already been made. So that's a tough one to compete with. You have to, again, it takes a large amount of education to be able to get people to understand that cost savings.
Yeah. Yeah. Can you talk about a few specific applications that you guys have used additive successfully for?
No.
What can you talk about? No. Can you give
I
us
can't get into
categories? Can you give
specifics
us
quite yet.
categories?
We've got one product that we're working on that I'm very excited about, and it actually is the one big laser powder bed fusion, metal laser powder bed fusion project that we're working on, and it's actually some machinery. It's not a part, it's not a tool. It's actually something that helps make parts on a traditional line. And that one I'm pretty excited about. That one is a part consolidation where we went from 27 parts to 6. And actually it's over half, it's half the cost of the traditionally manufactured assembly. So that one brings a lot of value. We also found that the traditionally made part was not as efficient as expected. It's a heating element, and it was heating unevenly. So by 3D printing it and doing the simulation and being able to print exactly what we needed, we were able to make that heating element consistent. So there's a benefit in terms of efficiency as well. So that one I'm really excited about, because hopefully we'll be able to turn around and sell it as an actual product. It's not an existing product at Hubbell. And then I'll be talking about it, and you'll be tired of hearing about it.
Okay, well, I'm excited for those news then. Okay, but then on a higher level, so you did mention tooling application. You mentioned, and therefore some certain machinery components. You mentioned connectivity requirements. I'm guessing there's also parts you're thinking about printing that actually go into the grid. So really, there's no part of the business left out within Hubbell that you're not taking a look at.
Yeah, I mean, the focus is primarily on printing end use parts. That was, we're aiming to be a production facility, or tooling that supports end use parts. We have a couple projects like that. The only thing we're not doing a lot of, and we'll do a little bit of it largely just to fill the printers, or just to help out our colleagues, is prototyping. We have not been established to prototyping. With most of the facilities have an FDM printer or a simple SLA printer that they can do their own prototyping on. So that's the only thing we really, it's kind of the opposite of what a lot of people think of with 3D printing. Is that's the only thing we're not focusing on, is prototyping.
Okay, interesting. As you do lunch and learns, and as you do education in-house, I'm sure there's also engineers that now start to think, hey, I have an idea, I could maybe improve this application. Do you start to see people also now think about not only replacement, but also call it innovation with additive, where they're really trying to think about, okay, how can we really redesign, redevelop, or newly develop an application that Hubbell has not seen
Yeah, I
before?
mean, that's what we're getting into finally now. It's exciting because, again, I think when we started this, and there's always inherent, healthy level of skepticism. So to come in and expect people to immediately want to create new designs is just it would be naive. So we have been producing parts literally as they are. We're making, very little, if no, changes to the design from an additive perspective, unless it's something like part consolidation, but the part ultimately still looks exactly the same at the end. Um, but now finally people are starting to get it and they're starting to get excited. And there's a couple projects that I'm super excited about that we'll be working on, that we're working on now, just kicking off, where we're going to be making new products, entirely new products. And they were just ideas from one of the engineers at one of the facilities. And we're helping them in a collaborative way kind of come up with how best to implement that. So it's exciting now. I mean, we're being Hubbell, being the company that we are, and looking at who our customers are. That's where we have a little bit of a barrier. We had one project that was really interesting early on for the lineman and tools equipment division of Hubbell. Lineman is one of the most dangerous jobs, in the world, and they have their equipment that they're used to using. So we were working on this project, and we did this generative design that was really cool, solid parts, and it looked like alien. And they're like, "Look, you got to tone it down because the linemen are never going to be okay with using this crazy designed part. You've got to make it look more like it did originally." So that was a really funny, because even though the performance was better, even though it's cheaper, we have to be careful about looking at who ultimately the customer is and what they're comfortable with.
Yeah. My brother-in-law is a
Oh,
lineman.
really? Oh, that's cool.
Yeah, he's definitely a dangerous job for sure, for sure. Okay, so really, if I don't think about Hubble and the center of excellence, it seems like you're at the moment mainly focused on creating immediate value for your internal stakeholders, but then it seems like that there's also more and more of a transition into R&D support and really future development to help Hubble get into the next phase of grid modernization. I'm sure there's also a place in the data center build out for Hubble, or just in general energy production increases, where Hubble does have a huge role to play, and innovative technologies like AM, I'm hoping, can also help to accelerate that.
Yeah, I mean, certainly. It's as I think I said before, right now we're in the stage where we just simply have to prove ourselves and we have to prove that there's value. But I think we're just scratching the surface on the potential and what we can really deliver. I think a couple of years, a year or two from now, we're going to be making some pretty cool stuff that's genuinely going to, help modernize the grid. And that's very exciting.
Super exciting. If you think of somebody that's is in similar shoes that you were 2 years ago, meaning they either have the idea or even responsibility to build a center of excellence within their organization. What's your ultimate advice? What are some of the key learnings, but also pitfalls that you fell
Yeah,
into that's
I think
that could help somebody?
hopefully it's not disappointing because I feel like a common answer is a true answer is find those killer applications. We were fortunate to find a couple real killer applications at the beginning. And essentially, because those bring so much value, that allows us to do some of the stuff that's a bit more risky. I think, without that, I don't know how anyone would ever succeed. You've got to have a couple killer applications that makes everybody happy, and demonstrates the value. And, really, early on, it's that low hanging fruit, to make sure people get it. Because like I said, it doesn't matter how educated you are, how open-minded you are. There's always that decent amount of healthy skepticism when people are first introduced to additive. So you got to have those killer applications. I think the other one is just education and a really big focus on educating not just the engineers. Obviously, the engineers need to we focus very heavily on educating the engineers on identifying potential applications. They don't need to understand how the printers work. They don't need to be able to run a printer. They don't need, the deep dive, but they do need that education on being able to look at a part and say, you know what, if I could 3D print that, I could do this, this, and this and make it so much better. So that's a huge part of it. And I think that's an ongoing thing and never, it needs to be heavy from the start and continue being heavy all through because there's always new people to educate. But that's the engineers. But even more importantly is really the business side as well. So the finance team is probably our toughest audience. I think probably the finance team is the toughest audience at probably most all companies. But we need to educate them on what additive is. And, they come from a background that's more spreadsheet based, less tactical, or less, tactile. And so that's probably the more difficult ones is the finance side of things to convince them because they're used to thinking of things in traditional manufacturing. Again, even like SAP, we have to do a wholly different process because we're making parts together. That doesn't work with traditional manufacturing execution systems. You have to have something that specifically can look at a build and it has 20 different parts from 10 different customers. That's not how typical, big organization SAP and systems work. So we have to educate everybody, including IT and finance and the project leaders, obviously. So that's really important as well, I think, to get the ball rolling, and probably one of the biggest hurdles.
Yeah, and potentially also, therefore, one of the biggest upsides if you do that education right. If you get your support from the finance team, from the supply chain team, if they start to understand it, they may actually be able to identify use cases and applications that your engineering folks are potentially missing.
Yeah, exactly. And it's there's so many different viewpoints. If you look at a single product, right? The way the engineer looks at that product versus the way the product manager looks at that product versus the way that the finance director looks at that product, they're three totally different stories. And two of the three very likely would have nothing to do with additive manufacturing, but one of them might. And so you may have to make sure you've educated all three so that they're aware to be able to spot those advantages.
Totally agree. Well, Kristen, very interesting insights into your daily business. I think it's also somewhat of a testament to additive that you guys are being so successful in integrating additive for applications that aren't space applications, that aren't fighter jet applications where you have huge value opportunities, but that you're actually pushing the limits on the lower cost, high volume applications. And I think it showcases that the technology is continuously really ready for prime time.
Yeah. I think the industry has a bad reputation for it not being 3D printing not being adopted widely. And I think that's not true. I think there's a huge amount of companies out there like us, that can't talk about the parts they're making, can't, talk about the technologies, but they're really using additive manufacturing and using it for volume production. And, I think, the only ones that get, that we have the aerospace applications because they're cool. I mean, the SpaceX, Raptor rocket engine, I mean, that's just cool. The parts we make, not as cool. And it's less flashy, I should say. We think they're very cool, but they're definitely less flashy. So I think there's a lot more companies out there doing what we're doing. It's just they're not talking about it.
Yeah, I actually think the boring part are nowadays the flashy parts. If you can print a boring replacement part successfully with positive economics, I think that is the cool
we think
application.
It's definitely rewarding.
Yeah, as soon as you can show your parts and you can talk about them, I'll do my part in promoting the boring is sexy
Awesome.
message. Well, Kristen, thanks for being on the show with us. It was a pleasure to have you with me and talk about how you approach the Center of Excellence at Hubbell. Let's have you back once you can talk about those applications, because I think we all want to see them. But for now, thanks for being on the show today.
Awesome. Thanks, Fabian. Thanks for having me.
Yeah, and thank you out there for tuning in. If you enjoyed this episode, give it a up to 5-star review on your favorite podcast platform. If you have questions, shoot Kristen or I a note, ask questions on YouTube or your favorite social media app. I'm Fabian Alefeld, and this was the Additive Snack Podcast. I'll see you next time.